thanks to Jim, who's been working diligently to try to solve some noise problems at his QTH. And one of the things that I think we both felt, or we both experienced, is people that compare things don't use a real scientific method. You'll see on eham.net, for example, people say, "Oh, I just bought this new antenna and it's the best thing I've ever had, and I'm now working this part of the world that I never did before." Well, he had never tried that time of year or that time of day before. So Jim wants to make sure that what he's doing is scientific and repeatable. So he's come up with some very innovative ways of comparing antennas and noise levels and so on, not just at his own QTH, but with others in the area or even outside the area. How much am I hearing? What can I hear? And so on. So without much further ado, we'll move to Jim, if you want to start sharing your presentation and tell us what you're up to.
This story began last November. The end of November, the CQ Worldwide Contest, CW contest, November 28th, I think. And for the past, I don't know, 15, 20 years that I've been at this house, I've never had a real bad interference problem. And of course, 3 hours before the contest started, the noise started. And it was really, really bad. It really put me off the air for more than half of the contest. It would come and go. And it's the first time it happened to me. And so I was determined that I got to do something about this. So that's why it came to this. So my plan is to, after doing some reading on receive antennas, came up with an idea of doing some phasing and a couple of active verticals as a standalone receive antenna system. But how to test it? How do I know it's going to work better than my existing vertical? And so I came up with using WSPR. And that's why this has been voluntary. If I didn't have that QRN problem, we wouldn't be talking about this, but I do. Now, this is not strictly speaking about WSPR, although we'll be talking about it. WSPR is weak signal propagation reporter. It's been around for quite a while, probably, I want to say at least 10 years, probably, see, 2000, no, a little bit more than that, 15 so years ago, the FT8 came out, WSPR came along as well. And Joel gave an excellent presentation on WSPR by itself back in 2023. And that is on the CARA website. And there's a link to it there, but we can put that at the end of the presentation. Anyway, so he talked about WSPR back then, and it was a great presentation. And I had a look at it. You should have a look at it after this. This presentation is not talking about WSPR by itself. What I'm doing is using WSPR as a tool to compare antenna performance, to compare one antenna against the other, and do that objectively, not subjectively. So my new antenna won't work better because I paid more money for it. It'll work better because I was actually able to measure in dB how it worked. And you can use WSPR to do that. And it's just a wonderful tool. So my objective is to measure the signal to noise ratio and actually qualify what I am seeing. So I can come up with a number, not something like, well, this sounds better than the other one. So I'm only using WSPR as a tool. Currently in my backyard, I've got a vertical antenna. It's a Hustler 6 BTV. It's a 6-band vertical. And right now I'm using it for transmit and receive. But what I want to do is add a dedicated RX, a receive antenna system, and hopefully to improve my signal to noise ratio. I'll talk about signal to noise ratio very soon here. I'll describe what it is and what it does and what it means. Now, what I want to do is put either loops, active verticals, both, and switch them. along with a phaser, a DX Engineering phaser, so that I can hopefully phase out some of the noise I've been having. So that's my objective. That's what I want to do, and I want to use Whisper to do it. So if anybody's used FT8, you have an idea of what Whisper is. It uses very low power transmissions, very low power, anywhere from 10 milliwatts to 5 watts. In general, 5 watts is a high powered station using Whisper. And you just send and receive signals across the world. And these transmissions are decodable down to a very, very low level because they're 2 minutes long. I think FT8, if I remember correctly, is 15 seconds, Jerry?
Yep.
15, okay. So the longer the transmission, the deeper you can go. Anything that's transmitted on the Whisper frequencies are decoded and uploaded to a database, a global database that's accessible by anyone at any time. And you can go back in time, back 10 years or more if you want to see what was going on. It's very helpful for doing propagation studies, but it's also very useful for measuring your transmit antenna, your receive antenna, or both. And so you can look at the signal pass and propagation effects in real time. It's really quite something. So how does it work? Well, unlike normal amateur radio transmissions, you don't expect an answer. You don't call CQ and expect an answer. You just transmit or you just receive. If you transmit, other stations around the world will receive it, decode the data according to the protocol, and there's a lot of information in the data string, as you can see here. I won't go and read it off. And this data gets uploaded to a database if you so allow it in your Whisper configuration. And either you or anyone else can have a look at how these signals propagate. So there's two modes, obviously. There's transmit mode and receive mode. In transmit mode, you can test your transmit antenna and see how it works. You simply transmit for some hours at a time, and then you can go on the Whisper site and see who heard you around the world and how well they heard you around the world. You can go and look at the signal to noise ratio, how you were picked up, and it's extremely useful for the other stations to see how their receive antennas or propagation is working. So that's transmit mode. Remember, you just transmit. You don't expect to receive anything. It's a one-way street. In receive, it's the other way around. Well, here, and this is the mode that I am interested in. I just want to see how well I can hear other stations, because by doing so on one antenna and then doing it on the other antenna, I can see which antenna works better. And it's not just a feels good thing. You can actually measure the signal to noise ratio. And so this was the whole idea, to see how my new receive antenna system will work better than my existing transmit antenna. And I'll use Whisper to do that. And the technique is surprisingly easy. I wasn't able to find any information on this when I first started, with the exception of a group that was based in Switzerland that was doing some loop antenna measurements, one against the other. And so I came up with the idea of using Whisper to do comparisons between my transmit antenna and my receive antenna. So back to the contest. This is what I was looking at on my waterfall. This was unreadable. I think there's only one station or so you can see here in the middle, another one over here. I think this one was Jerry, who was about 2 miles away from me, and I wasn't hearing anything else. So the contest was doomed. So this is what I want to get rid of, all this this noise down here. So I think I've said some of that. Propagation reporting. It is an extremely good analysis tool, and it takes all the guesswork out of it. Okay, so signal to noise ratio measuring. So what is that? Well, so with kudos to Bob Pease, and he's worth looking up if you want to look for a colorful character after the meeting. It's a measure that you can use to actually see what the signal that you're looking at in relation to the background noise is like. So it's the ratio of the signal to the noise. It's almost obvious if you have a very weak signal and you have a lot of noise, you're not going to hear anything. If you have a really strong signal, it doesn't matter really how much noise you have, you'll hear it. But typically what you're looking for is a good signal to noise ratio. And this signal to noise ratio is measured in dB. Usually it's a negative number. If it's a positive number, it's very strong. Excuse me, I gotta have some water here. So if it's a very low signal to noise ratio, then the noise is dominant and you won't hear the signal. And the beauty about Whisper is it's got the ability to listen down to a very low level, something that the human ears couldn't discern, down to over minus 30 dB. Signal to noise is measured in dB. So here's if you were to run your FT8, you would see a screen like this. In Whisper mode, this is what you see. You see down, oh, sorry. I hit the mouse button. So down here, you see it's in Whisper mode, but it looks like a little bit like FT8. This column here is really the interesting column for me, because this measures the signal strength that the antenna is delivering to the radio. You can see down here the signal I've circled at minus 30 dB. Well, that's a pretty low level signal. It's almost right at the noise level. So my feeling is if I can use Whisper to measure this on one antenna and measure it on the other antenna, and on one antenna I see minus 30, on the other antenna maybe I'll see minus 25, I know that my other antenna is working 5 dB better than this antenna. So that's the whole idea of what I'm doing here. We'll look at some of these other columns in a minute. So here's an example. So I found one YouTube video when I was doing my research here. Yeah, if you can't measure it, you can't improve it. If anybody's seen my QRZ page, you'll know I'm a bit of a test equipment junkie. I like measuring things, as Gary McDonald will attest to. So how do you measure it? You use Whisper. Now on this screen, somebody had measured one pass of a FT8 signal at minus 12 dB, WA2MCR. And then he switched on his receive antenna phaser system, and the signal increased to 4 dB. So that's a 16 dB improvement, which is huge. That's a great improvement in signal strength level. Well, maybe not signal strength, because really signal to noise. Maybe the signal did increase, or maybe the noise just decreased. It doesn't really matter. The signal to noise ratio increased by 16 dB. That makes a big difference. So when you transmit data or when you receive data, there's a website here, one of a few websites, whisper.VK7JJ. And this is a typical receive session that I did with my existing transmit antenna. So just look at the first row, for example, KHCHY. If you look across, you can see my call sign, RX call. So that's the in my receive session, I received all this data and I uploaded all this data to the global database. It gets uploaded automatically by the WSPR program. But here, his signal to noise is -18. Some of the other interesting information too. The K is the how far away he was. So he's 3,000 kilometers away. The mode, and how many kilometers per watt. That just kind of like a statistic. If you look here, he's running 1 watt. And down here, some of these guys are running 5 watts, and some guys are running 200 milliwatts, a lot of them. And so that's not very much power over some distance. The other interesting thing in this table is the compass direction is also given. And that can be very helpful if you're looking at your antenna in terms of directivity. So if you look at map, if in the previous slide you go and click on map here, you can visualize all this data and what it actually looks like in a map. And so here's Calgary, excuse me, and all the stations that I heard are represented on the map here, right down to South America, Panama, and including one a balloon. Somebody put up a balloon here, and this guy's only running 10 milliwatts. So, and his signal to noise was -27. So he was kind of weak, but that's fine. So what am I going to do with this? Well, I can take all that data you just saw, and I can bring it into Microsoft Excel. And if I'm going to measure my antenna performance, I want to measure it over a number of hours, a day or something like that. I can take all that data and import it into Excel. And then go ahead and convert the signal to noise from dB to a linear value. -3 dB is this in a linear value. Add everything up, average it, and then convert it back from linear to dB. And down here at the bottom, that would be my dB average for 8 hours or however long I choose to run this program. So that gives me a number that I can apply to either my transmit antenna or my receive antenna, and then compare the other antenna against it. If I can do better than -11.649 dB on one antenna versus the other antenna, I know which one is working better.
Jim, if I can
go ahead,
jump in just for a sec. When Jim and I were going over this, I wondered why he needed this extra step. What he's doing is you can't just average dB because it's a logarithmic value. So he's actually converting it to a linear number by putting it to the power 10 to that power. So you can average linear numbers, and then with that average, you can convert it back to the dB. So that dB average now is a meaningful number. So this is something that you have to do the calculation if you're going to be averaging decibels. And he chose to do it in Excel.
That's right. That's right. You can't just add up dB and take an average of that because it's a nonlinear number. And so in the end, it's rather easy to come up with an average signal to noise ratio by doing it this way. But it's an accurate measurement because these numbers are accurate and they're repeatable. So that makes measurement rather easy, actually. And there's a number of other good tools that I'm just about to show you that will help you visualize all that data. And all you need to do with them, they're so-called dashboards, is go to the website and just use them. And so here's an example of measuring an antenna graphically. Now, I don't have my second antenna working yet. One of the things I was going to do is with Jerry is to measure two of his antennas and compare them. So I picked another antenna somewhere in Alberta that I wanted to measure mine against. It's not really a level playing field here because VE6JY has much better antennas. But all I was interested in doing here is refining the technique of measuring one antenna against the other antenna. So the red line is me, and the green line up there are VE6JY super antennas. But the takeaway from this is that you can see a correlation between what I hear and what VE6JY hears. He hears way more than I do. That's the
And
number.
explain the y-axis.
Right. This is the number of stations that he hears versus the number of stations that I hear. As
Versus
well.
time.
What's that, Jerry?
It's over time.
Over time, yeah. The time is on the bottom here. It's 20 GMT to 02 GMT, so it's a couple of hours here. And towards this time period here, you can see that I'm not hearing anybody, and he's still hearing people.
So at the beginning, he's hearing about 300 stations, and you're hearing under 200.
Right, right. So even though it's comparing my antennas to his antennas, which is an unfair match, the same technique can be used to compare my vertical against my new receiving vertical in the backyard. And so I can graphically see that, yeah, there's a bit of a difference, better or worse. I don't know yet.
So
for
minus, sorry, Jim. So
yeah.
To hear a station, it has to be decoded, which means it's minus 30 or better dB signal to noise. So that's why one antenna can report more stations, or one system can hear more stations. It's actually more sensitive or has better signal to noise.
That's right. That's right. And so this is my this is going to be my tool of choice. On the group that I mentioned earlier, the guys were using this same program to measure one loop against the other loop, and so the numbers were very, very close. But you can see that there was a difference. So it's an excellent tool. And all you need to do to use this is just plug in the one station, the other station, the band, and away you go. And the time, sorry, and the time. And this is the website up here, Whisper HB9 VQQ. Are we good so far? Carry on. So this is another visualization of antenna performance. And it carries on from the previous slide, but you're looking at data in a slightly different way now versus the number of stations that I was looking at in the previous slide. Here, you can see that if Calgary is in the middle here, I can hear stations out this far, but JY can hear much further away naturally. Also over here, I'm not hearing anything in the northeast direction, but JY is.
That's
so
Europe.
Improvement that I could do. Go ahead, Jerry.
The northeast is Europe?
Northeast is Europe, and that's a big one. See, southeast is no problem, but northeast, I'm deaf in this way. Actually, down here, you can sort of see something happening, but not that much compared to JY. Okay, so this website is Whisper Live. So those are two of the websites of choice that that I would use to do antenna measurement. Just those two. Okay. So,
So, Jim, I got a question,
yeah, go ahead.
and maybe you're getting into it, but when you're comparing your antenna, are you comparing your antenna against somebody else's? Or are you
Yes.
comparing two antennas in your backyard?
Well, my goal is the whole idea is to just measure my antennas in the backyard. My transmit antenna to my receive antenna. But the problem is I don't have my receive antenna up yet. It's still sitting in the box. But by
Okay.
doing what I've been doing here, I can buzz through the technique and perfect the methodology of which I'm going to do this. So whether I'm measuring my antenna against somebody else up in Edmonton or my antenna against my other antenna, the techniques or the methods will be the same. But I don't have a second antenna to measure against. And that's the only reason I'm doing it this way. So when I get my other antenna up, I'm going to see VE6JF /1 versus VE6JF /2. And I don't expect a whole lot of difference between them, but I'm hoping there's some. Does that help?
Yeah, does help. And I also was wondering if you did have a second antenna in your backyard. I guess you could take the difference from uh, somebody else's antenna and still get results that would tell you something. Is that correct?
No, if I'm comparing my antenna to, let's say, Jerry Spring's antenna, it's interesting, but it doesn't tell me much because his antenna I know is working better because we did this actually as a test. His antenna is working much better than my antenna. So it isn't not a level playing field. I've got to measure my backyard antenna against my backyard receive antenna because that's the only two antennas I can use in real life.
Okay.
But by measuring it the way I did, I can test out the procedure or the technique that I will use in order to do it. So
Okay.
you see, whether I test VE6JF versus VE6JY, well, that's not really, that's kind of an academic, experiment. What I really have to do is test VE6JF against VE6JF/1. And you can do that in Whisper. You can run an alias, so you can run two instances of Whisper at the same time under your call sign with some kind of an identifier like /1 or /2 or /L for the loop or /V for the vertical. And you get two sets of data, and then you can do a direct compare of that data. And it's very meaningful when you do it that way.
Okay, I got you. Okay, thanks.
Oh, good. Okay. So there's a few ways to do it. And I've only done it one of these ways yet because I don't have my receive antenna set up yet. I started to unbox it and it's all there. The pieces are there. I just have to get it up. Had a couple of distractions recently. So one of the things when you're measuring an antenna is that you probably don't want to leave a lot of time between testing one antenna and testing the other antenna. Because what happens when you do that? Propagation can change over a short period of time. And so that makes the numbers, the data that you get back less accurate. So the ideal way, and I haven't tried this yet, I just got the hardware installed in my PC last week. I've got I have two sound cards now that I can use. And I also have a dual channel SDR. So my theory, my idea is I'm going to use my two antennas, transmit antenna, receive antenna, and I'm going to run them into the dual channel SDR. And I'm going to run that into my PC. into WSPR, WSJTX. And I'm going to run two instances of WSPR, instance 1 and instance 2. Instance 1 will be connected to antenna 1, and instance 2 will be connected to antenna 2. And then I'm going to have two sets of data as a result of all that, V6JF/1 and V6JF/2. So I'm going to have duplicate pairs of signals in the WSPR database, differentiated only by the /1 and /2, and of course the antennas. And so I can compare those two data sets against each other. So this is like the ideal configuration because one radio, one PC, and the only variable are the two antennas. Propagation is not a problem because I'm doing everything at the same time. So that's my configuration number 0. So number 1, this is also a good way. A little bit not that ideal, but not terrible either. Having two receivers, having two PCs, and having two antennas. So these receivers can be anything. It can be an SDR, it could be your transceiver, your 7300 or whatsoever, and two PCs and running each one instance of WSJTX. Assuming the receiver specs are more or less identical, and this being audio, it's not much of a problem, you wind up with pretty close to the same thing. And the beauty of this is that any propagation changes won't matter. So in this configuration, I've only got one instance and one receiver. So if you're short on hardware, then this is also a way you can do it. If you run WSPR for short periods, like 10 minutes at a time, and switch back and forth, then you don't compensate for propagation changes within 10 minutes. But I think in the overall, this is not too bad, and this should work out okay. So there's 3 different ways to do it. And in my case, what I'm trying to do is have 2 vertical antennas, loops or verticals. I'm building some loops, and I bought some verticals. Going to put them up. I don't have a beam, I have a vertical, but the idea is to use a separate transmit antenna and separate receive antennas and phase them, and hopefully reduce that noise I showed you. Now, let me just back up a second. This is pretty much it. So that covers everything I want to do with my objective with having a separate receive antenna system and use WSPR to do it, to do the actual measurement. I put this in here because this is not really related to WSPR, but only in one sense, I guess I could say. This is the my QSO map of the contest that started out as a big failure for me last year, where I had all this QRN. But this was my result at the end of the contest. So you can tell from here, from Calgary, the majority of stations for me are down in a southeast direction and a northeast direction. And this direction here from Calgary, this is northeast. This direction here, excuse me, is what I'm having the most problems with. And so if I can increase my receive antenna system in this direction, I'll be a happy chappy. Not so much in this direction, although there's some. But the other interesting thing about this map is that all these results, and I mention this for people that are a little bit maybe challenged with antennas, I only have 100 watts and a backyard vertical. And this is how I did in the contest last year, even with all the QRN. So I guess I'm trying to say is you don't need a lot of power and a big antenna to make really good contacts in a contest.
This is CW.
What's that?
We're using CW as your mode.
Well, yeah, there's that. So CW gives you a tremendous advantage, signal to noise ratio. And so, yes, all these were CW contacts, but you can really do well with 100 watts to a backyard vertical. And that was just a bit of encouragement. I want to give everybody that thinks that they really need their antenna's not working very well, or you need a tower and a beam. It would be nice, but if you don't, you can still do a lot with a vertical. That was my only point with that slide.
So
And what's that?
I wanted to point out that you had chosen JY as probably one of the biggest stations in Canada to compare one of the smallest stations, or a modest station anyway.
Well, yeah, no, not really. There was another station up in Edmonton, but I couldn't find the data that I wanted. The advantage to using JY is because he's pumped tons of data into the WSPR database. And so there was a lot of readily available data on different bands. And so that's why I chose him. Yeah, not because he has bigger antennas than we do, no. But there was a lot of data. And that was very helpful to be able to find data when I was running my system.
So when you look back at the techniques you've developed here, the number of stations you hear, is that the sort of the main one you would look at?
I'm sorry, say again?
You showed that one graph of the number
Yes.
of stations from, let's say, antenna A versus antenna B.
Right.
So is that the primary diagnostic graph you would use to see if this
Yes,
antenna is better than that other one? I'm hearing more stations.
that is correct. Yeah. In sheer terms of the number of stations, but I'm also kind of interested in the direction. So I would look at the other website too that highlights the direction, not just the sheer number. Although there's probably a correlation between the two, because if you hear a lot of stations, chances are it's working pretty well. The other thing about the WSPR database is that on any given day, the sheer number of points that are put in the database is astounding. There's somewhere between 240,000 and 275,000 points per day being deposited into the data every day. Some stations run 24 hours a day. Some beacons, there's a lot of beacons around the world. The group that I belong to is the Beacon Project, and they, I think Sid has a 5-watt WSPR transmitter that when it's running will deposit its data into this global database. So, yeah, that's all I got to say.
So one of the other things you mentioned you're thinking of doing is phasing the two verticals.
That's correct.
Would you be phasing them to reduce noise or phasing them to favor the northeast?
Initially, what my intent is to phase them to reduce noise. But I don't think you can do one without the other really, because they're going to be pointed in a certain direction. But since you and I talked about that, Jerry, I'm halfway finished a switching antenna box that is capable of switching 3 verticals or 4 loops in combinations so that I can change direction, much like a 4-square array. So this is going to be able to favor northeast, southwest, whatever I want to do. Well, I won't use just 2 verticals. I'm probably going to have 3 verticals and initially 2 loops, but I provided for 4 loops. So I can pick combinations of them. And hopefully between those combos, I can reduce not only noise, but possibly also get some directivity out of it. And that's what's going to, that's my objective. There's a lot to it, and I've only just got started.
Yeah, I was just thinking that if you use that NCC box, you can set your phase angle, whatever you like.
Right.
So and the whisper reception is every 2 minutes. You
Yes.
receive another signal every 2 minutes. So in theory, you could be switching like 45 degrees, 90 degrees, 135, and so on. Just keep going and compare signal to noise every 2 minutes with another jump.
Yeah, that's right. But it also opens the door. Like I'm not bound to whisper to do that. I can use FT8 because all I'm looking for is a good signal to noise. So if I wanted to do any short-term listing or testing rather, I could use FT8 and take advantage of the 15-second transmission times and get quicker resolution. The only advantage to doing that is doing it this way rather than doing it on single sideband or anything else is because with FT8 or Whisper, you get an actual number that you can look at. And so it's a very objective number. It's a dB number. And so you can compare one transmission to the other or one antenna to the other. Remember, out of all of this, that's the key point, just to get a number. Not an S meter reading.
But if you use FT8, you're not getting into the database. You can't review it.
No, that's true. And that would be the only thing that I would use for doing, sitting down and doing a quick test. But for long-term tests, you can't beat Whisper. And usually long-term tests is what I want, not just a short-term one, because that could be propagation. And so I would run it for, let's say, 4 hours or so, and then download the data and put it in Excel and analyze it and see how it compares.
And how it compares on different bands?
You can compare on any band, yeah. My noise problem is usually it's below 15 meters, although I've had some noise on 15. But this system works best at on the lower bands because typically there's a lot more noise on 40 and 80 meters than other bands. So.
I'm out of questions.
And I'm about it, unless you have any more questions. That's the end. And this is Bob Pease's actual desk.
There's a great picture of Bob Pease in his red Volkswagen Beetle, and it looked a lot like that also. So the other half of his research papers, I think, were in his Volkswagen Beetle. In that.
Yep, that's right. You know about him, right?
Oh, him and Jim Williams, yeah, were quite the pair.
Yeah, yeah. Just as a side to that, Jim Williams was also a very famous analog engineer, and they worked at competing companies, but they were good friends. And Jim Williams died of a heart attack, and Bob Pease went to his funeral, and on his way home, he was killed in a car crash the same day. His Volkswagen.
You should never go to funerals.
Yeah, it was a really sad day. These were very colorful characters back then. You've seen the Bob Pease show, I guess, Jerry.
Yes, I have. Yeah, yeah, some of the best analog minds, like I say, of probably the last. I don't know if we'll ever see, guys like that again doing the type of research and
Yeah.
engineering they did. It's all gone digital in that now.
Yeah, it's a different time. They were pure analog guys too. He won a contest in Northern California for the Northern California's most messiest desk. True story. No, true story. He won $500 for having that desk. And he went out and they bought pizza for the company. And they had pizza.
Never found the certificate.
No, I think, no, actually, there's another anecdotal story there. They would test Bob Pease to see if he could locate a given paper or papers or spec sheet or whatever, and he never failed. He always, they come in and pick a spec sheet and say, hey, where's the specs for, I don't know, an LN 317? And he'd root around there and he'd pick it out. So it wasn't just for show.
It was a mirror of his brain.
Yeah, he's very creative. And so, guys, that's all I got. I hope it helps. I'm confident this is going to work out. I don't see what can go wrong, actually, because people have done it before. And so all I have to do is put the antennas up and get going. I'm not worried.
I think it opens up a real avenue for all kinds of antenna testing. For example, do I need 1 or 2 radials, or what happens if I add 12 or 16? Is 32 overkill? You know, you could compare all those over time as you lay them out and publish a paper on that. And some people have done that without WSPR.
Well, that's true. You could also see how your, let's say your inverted V is compared to your vertical in your yard on any given band. You can do that. You know, the other variable, actually, when you think about it, is time of day, which works better at any given time of day because propagation is going to change from maybe ground wave to sky wave. So you can do testing by letting WSPR run and looking at the data and saying, you know, in the evening, I'd be better off using this vertical than my dipole because of NVIS. So there's a lot of things you can do with WSPR in terms of antenna testing. So I'm kind of happy that I stumbled across doing this because you can learn a lot.
And one of the age-old questions is a vertical a better DX antenna than a dipole? And there, of course, there's all kinds of variables that you can throw into both antennas. But you know, it's the old low angle radiation, low takeoff angle vertical, which should be in theory better for DX, but it's also a noisier antenna. So how does the signal to noise compare, you know, if the DX is strong enough or whatever, compared to a dipole at a certain height in wavelengths of the ground and your ground conductivity and so on. So you could actually model and measure those and get actual numbers by.
That's right.
I could compare an inverted V, my backyard, with Jim's vertical on the same band and the same time.
And we can see about the you know, the legend about a vertical versus horizontal, which is noisier. You can measure the noise if you run both at the same time. You can look at the vertical and then look at the signal to noise of the beam and see, you know, is it vertical really noisy? Because I'm not convinced that vertical is. I've only had a vertical since I've been here, and there have been many years when I felt like I was in the country. It was so quiet using the vertical. Of course, not last November during a contest, of course, but even today, like the noise will come back from time to time, but it's not nearly as bad as November.
We're waiting for the contest to start up again.
Waiting for the contest. That's right. People put their Christmas tree lights up and I'm done. Yeah. But I'll be ready for them next year.
Very good. Thank you, Jim. That's great. Other comments, questions?
Disparaging comments?
Well, I did hear that magnetic loop antennas are really good at reducing noise and used for listening.
That's correct.
I was wondering if you'd considered modeling a loop.
Yes, I have one under construction, and I plan to build 2 of them as a minimum. I'm going to use the LZ1AQ amplifier for it. I've got the hardware built. I've made it out of hardline coax, very low inductance, and some thicker coax would be better if I can locate some. But I'm going to build the amplifier. I've actually built one, and as Jerry McDonald saw, I screwed up the PCB, but I'm going to build it again and make it work.
This is a broadband loop, right?
A broadband loop, yeah, it's just a receive-only loop, and I've modeled it in the amplifier and the loop in LT Spice, and it is pretty flat from about 500 kilohertz right up to 30 megahertz, quite flat, and over 50 dB of gain. So it's really a pretty high gain antenna. And you're right, they are apparently less susceptible to noise because they operate in the magnetic way rather than the electromagnetic way, EV way. And so they should be, by its nature, quieter. They are also, depending on where the skywave is, they can be somewhat directional, not like a beam, but they are bidirectional with the null off to the side of them. And so they would be probably if I'm doing any directive testing, they would probably be the most ideal antennas to try to phase. I wasn't going to rotate them. I thought it'd be easier to build 4 of them and point them in various directions. Much easier, much cheaper, much easier, very cheap. And just as effective too.
I'd be really interested in the results of that and how they're constructed.
Yeah, it's actually surprisingly easy to do. The LZ1AQ is a pretty good amplifier, and it's been around for a while. A lot of them have been built. It is kind of a commercial one, but the schematic is readily available. And
Jim has the PC board layout.
yeah, I've laid out, I got some surplus boxes, and I've scaled the PCB to fit within these boxes. And I happen to have 4 boxes, so, or at least 4, maybe 5 or 6. And I'm going to put the amplifier in the box and power them using a bias T with 12 volts. You know, one of the other interesting aspects of all this too is that you really need to turn off the power to the amplifier when you're transmitting. And I've built up a method to do that. It's part of my antenna switch. So when I go into transmit, the transceiver actually sends a signal to the phaser, and it disconnects via my antenna switch box. I've added some relays so that it will disconnect the power to the amplifiers. So the receive antennas can be very close to the transmit antenna. Because there's no power on the amplifier in the receive antennas, it won't blow up.
Don't you actually need to short circuit the transistor?
Well, it's a good idea, and I'm doing that. I have a relay out in the amplifier box, and when power is removed, it shorts the antenna to ground. Yeah, safety first.
So as an aside, I just wanted to mention that I saw a commercial loop antenna in Pump Hill when I was driving northbound on 14th Street. About maybe a kilometer down, you look on your left and there's a guy there with a vertical in this huge, beautiful magnetic loop. It's made out of brushed aluminum, and it's probably 3 inches in diameter.
Wow.
And the loop itself has got to be at least 3 or 4 feet. So I'm pretty sure it's the 80-meter loop. I looked at it on DX Engineering. It's 3,500 US.
Yeah.
That's Eugene. It's not my antenna. It's Eugene. He's my neighbor down the hill.
Oh.
Oh yeah. It's a thing of beauty.
Sorry.
It's hard to believe. It's the commercial one is about 3 feet in diameter, like DX Engineering, like the one you saw. Rather expensive, but depending on the diameter, it makes for lower inductance, so it makes for better performance.
I built a loop for 160, about a 3/4 inch diameter hard line, and it's a receive loop only, and it's got a very high Q, so you have to be very careful how you tune the capacitor in there. But it works great. And so if I'm hearing, on 160, my noise level is typically S9 on any given night in the winter. When I turn my loop on, it drops down, the needle goes down to like nothing. And so what I can do is I then kick in there's on my radio, there's 2 levels of preamp in the RF gain. So I can kick it out to maximum, and I see a noise level when it's on preamp 2 of about S2. And it's huge. So what I discovered was that I can hear so much better, and when I transmit, still nobody hears me. So it's been
It
kind
sounds
of,
like you really reduced your signal to noise ratio there, Jerry.
what's that?
With the loop, it really reduces your signal to noise ratio.
The loop improved it.
It improved your signal to noise.
Yes. I can hear so many more stations,
That's right.
but nobody can hear me because I'm not transmitting on. I mean, I've still got the same transmit antenna, which is I load my tower, and I have problems for whatever reason, probably the way my radials are laid out in a 180-degree pattern.
Right.
Certain lobes are created, so I can't be heard in the Caribbean or whatever. My house is in the way.
But you have to start with receiving, because if you can't hear them, you can't work them.
Right. Although a lot of I think the American way is to maximize your power first, and then cause as much havoc as you can, and then maybe you'll hear something.
That's one way.
There's a lot of kilowatt stations in the US on FT8. The weak signal mode.
I don't think I've seen a station more than about 20 watts on Whisper.
Right.
The overwhelming majority is 5 watts or less.
Well, I think they would probably get notified pretty quickly, because if they were more than 20 watts, they would probably be causing a lot of harm to the whole system. It would overwhelm a lot of these very sensitive receivers.
Hmm.
Comments? More questions for Jim?
That's it for me.
Thank you so much, Jim. That was great. And we will stay tuned to find out how you do it. If you need a hand putting up the other antennas, let me know. I'll be happy to drop by.
All right.
Any other questions, ham-related questions from anybody